Hi viewers, in this video we will solve example 4.2 from the book Applied Thermodynamics and Mechanical Anti-Stops. So here is the statement of the example 4.2. A rigid cylinder of volume 0.025 meter cube contains steam at 80 bar and 350 centigrade. The cylinder is cooled until the pressure is 50 bar. Calculate the state of the steam after cooling and the amount of heat rejected by the steam. Sketch the process on a TS diagram indicating the area which represents the heat flow. So what we need in this example 4.2, we need to find the state after cooling, whether it will be on the saturated regions or on the wet regions or on the superheated regions still, and the amount of heat rejected. So the state 2, we need to determine where it will locate. So we need to find its locations on the TS diagram. These things we need to determine, and the next is to determine the heat that is rejected. This and the third thing, we need to sketch a TS diagram. Before further proceeding, let me show you the TS diagram. This is the TS diagram. So we have two pressures, that is 80 bar and 50 bar. So the highest pressure in this statement, that is 80 bar. So I have shown it from this curve line, that is 80 bar line, and the next line that is in this statement, that is 50 bar. Now the gas data that is given in the statement is the pressure P1, that is 80 bar, temperature T1, that is 350 centigrade. After cooling, the pressure P2 that is given is P2, that is 50 bar. The next thing, we need to find the specific volume, and also we have given the volumes of the cylinder, that is 0.025 meter cube. So the pressure P1, T1 value lies in the superheated region. I have extract the portion of the steams and shown on the screen, that is our concern. So the 320 and 360 centigrades and at pressure 80 bar is lie in the superheated region. So that's why we say that the state point S1 is lie in the superheated region. So it will be lie here. So this is the state point 1. If you see that the temperature 350 centigrade is not available on the steam table, so if any value that is not given in the steam tables, you have to put the upper value, you have to get the upper value and lower value. On the basis of that, you will find the corresponding value that you needed. But for that you need interpolations formula. So we need to find the specific volume at the state point 1, so that is VA plus VB minus VA divided by temperature difference, that is TB minus TA into T1, the temperature at which you are finding the specific volume, and TA. Remember, what will be the values of V specific volume, B, A, T, B, T, A? That is you can get from the superheated steam table. Here I have extracted the portion of it. This is TA value, this is TB value. Similarly, this is VA value, this is VB value. Similarly, this is HA value, and this is HB B value. So the upper value is for subscript A and the lower value is for subscript B. Now put these value in the corresponding formula of interpolation. You will get the specific volume. Let me put its value. So the corresponding value of the specific volume is written in the formula. So the temperature difference TB minus TA, that is 40, and the original temperature at which we are finding the specific volume, that is 350 centigrade, minus TA, that is 320. Its difference you will get 30. So this 0 will be cancelled out with this, and you will find that specific volume is, after simplification, you will get its value, that is 0.029 meter cube per kg. Next thing we need to determine is the mass. How much mass is contained in this rigid cylinder? So it is equal to volume divided by specific volume. So what is the volume? Volume is 0.025 divided by 0.0299. So the mass you will obtain after simplification, that is 0.836 kg. Now similarly we will calculate by using the same interpolations formula to find the enthalpy value. So that will be equal to H1, that is HA plus HB minus HA divided by TB minus TA multiplied by T1 at which you are finding the enthalpy minus T. So all the enthalpy values, that is VA, VB can be seen from the superheated steam tables, and just put the values in this formula, interpolation formula. You will get the approximate enthalpy values. So after putting the value, you will get the H1 value, that is, I directly write the enthalpy values, the corresponding enthalpy values from the superheated steam tables that previously I have shown, and its temperature at which we are finding the enthalpy value. So after simplifications you will get, this is the interpolations formula. So this H1 value you will get, that is 2985 kilojoule per kg. Remember, the interpolation formula will give you the approximate value, not the exact value. The next thing we need to determine for the state point 1 is the internal energy, because without internal energy, because it's a cooling process, so internal energy is equal to H1 minus P1 V1. So what is the internal energy? U1 that has to be determined. So enthalpy is 2985 minus pressure P1, that is 80 bar, divided with 10,000 divided 1000 to convert that into kilo. And next is the volumes. What was the volume? That is 0.025. Sorry, it's a specific volume, not a volume, remember. Okay, what is the specific volume? That is 0.0299. So after simplifications, the internal energy you will get, that is 746 kilojoule per kg. This is the internal energy at state point 1. Now for state point 2, we know that the pressure that is given P2, that is 50 bar, and the specific volume that is constant, because we have already given here in the statement that it's a rigid cylinder, so the specific volume is constant. The previously we calculated the specific volume at the superheated steam tables from the state point 1, that is 0.0299 meter cube per kg. At this pressure 50 bar and specific volume 0.299, we can conclude that where our state point will lie in the TS diagram. So from a saturated region, we can see that at a 50 bar, the saturated specific volume is 0.039 G12, that is 0.039 meter cube per kg. Remember, when U2 is less than this, V2 is less than Vg2, it means that our state point lies in the wet region. So here we can conclude that our state point lies at this point. So the first state point is in the superheated region and the second one is in the wet region. So the cooling curve will be like this, and its corresponding entropy will be S2, and this corresponding value will be S1. So this shaded area will give you the heat that is rejected on the TS diagram. I hope you understand why we have taken this state point within this dome shape, because it is in the wet region, because this volume at V2 is less than Vg2, that's why it's in the wet region. If it is in the wet region, there must be the dryness fractions, and that dryness fraction will be equal to V2 divided by this specific volume V2G. So V2, that is 0.0299 divided by 0.039. After calculations, you will get the dryness fraction, that is 0.76. Next, we need to determine the internal energy at the saturation temperature state point 2. So the U2G value, that is, next we determine the internal energy for the state point 2. Before that, let's come to the steam table. So at the saturation temperature 50 bar, the internal energy UG2, that is 2597, and liquid internal energy, that is 1158. So UG2, that is 2590. So after its subtractions, you will get the UFG2 value, that is 1449 kilojoule per kg. Now you can easily calculate the entropy at the state point 2, because the dryness fraction is determined. The UG2 value we can get from the steam tables, saturated steam table, UF2 values and UFG2 at subtractions, and the final U2 value is equal to UF2 plus X dryness fractions and UFG2. So just put the values and you will get the U2 value, that is UF2 1148 plus 0.76 UFG2 value, that is 1449. After simplifications, you will get that entropy at the state point 2 is 2249 kilojoule per kg. Now the heat that is rejected is equal to U2 minus U1. Also multiply with the mass to find the in term of kilojoule. So to remove the specific terms, the heat that is rejected is equal to, what is the mass, is 0.836, and what is U2 value, that is 2249 minus U1 value, that is 2746. So after simplification you will get its value, that is minus 415 kilojoule. The minus sign indicates that in this case heat rejection has taken place. Thank you so much for watching. Please subscribe and share my channels.